Alright, so this is a video tutorial for predicting products for double replacement reactions. So we're going to go through some practice problems for your notes. But before we do that, let's just remind ourselves what a double replacement reaction is and how we can recognize that. So here it follows the format of AX plus BY. So we have a compound and a compound. And in these compounds, we have a positive ion and a negative ion. And that's the same for both of these. The positive always comes first. So if a reaction were to happen, what would result is that the positive ions are going to switch partners. Or you could think of it as the negative ions switching partners, either way. But if that happens, then our products would, instead of AX, now B is with X. And B is the positive ion, so it will come first. And then the other product would be the combination of A and Y. And A is the positive ion, so it comes first. And of course, you would have to balance the charges of these ions in order to write the correct formula. But that's the general form of the reaction for double replacement. And the only way that this reaction is going to actually happen is if we get one of three possible products. So one of these products has to be either a solid or a precipitate, that's another word for a solid, or it has to be water or a gas. So if you get that both of these products are aqueous, according to our solubility table, so we have to use this to determine if the reaction will happen or not. If both of them are aqueous, then there's no reaction. And we would just write no reaction. We would not write the products. So we'll do a few examples to practice this. So all of these problems are double replacement, and we can look and see that it's a compound and a compound, compound and compound, and everything, notice, is aqueous on this side. So we're mixing two aqueous solutions and trying to figure out what the products are. So let's just go ahead and try some of these. Again, you will need your solubility table in order to figure out if these reactions will happen or if there will be no reaction. So let's look at the first one. CuBr2 reacts with AlCl3. So if these are our reactants, what's going to happen, we can think of it that the copper and the aluminum are going to switch places. So before we go ahead and write our products, we can save some time and just make sure or check whether this reaction is going to happen or not. So if copper 2, we know it's 2 because there are two bromines here, each with a -1 charge, which means this has to be copper 2+. Bromine is minus. Aluminum is 3+. Chloride is 1-. Alright, if the copper and aluminum were to trade places, then we would have copper 2 paired up with the chloride. So then you'll look on your solubility table, the cations are on the left side and the anions are along the top. So we look up copper 2, it's right here, and then we look up chloride, it's right here, and where they meet it says S. So the really tricky thing with this solubility table is that S does not mean solid. If you look down at the key, here, S on the table means actually soluble, which means it's aqueous. So far, we have one product that's aqueous. So we need to check the other one. The other product then would be if aluminum were over here with bromide. So we're going to check aluminum, bromide. So aluminum's right here, bromide is here. We check where they meet on the table. It also says S, which we know S means soluble, so it's aqueous. So since both of the products from this reaction are aqueous, Remember, initially we said if both are aqueous, then there's no reaction. So this equation's great because there's no reaction. So all you have to write is no RxN. So if you went ahead and wrote the potential products and then realized that they were both aqueous, you would need to erase those and then write no reaction. If you write any products at all for this reaction, it's wrong because those products aren't actually made. There's no reaction. Nothing happens when you mix these two solutions together. Okay. All right, so that's number one, no reaction. Those are nice. Number two, we have AgNO3 reacting with K3PO4. So again, we can think of it as the positive ions switching places. So before we write anything, let's check our solubility table to look at our potential products. We don't know if this reaction is going to happen or not. So silver was with the nitrate, but if they switch places, now it's going to be silver phosphate. So we look at our solubility table. Silver's right here, phosphate's here. Find where those meet. It says I. There's a capital I there. If you look on your key, I means insoluble, which means it's a solid. So that's a good sign. Once you see that, remember we got one of the three things needed to have a reaction, so we know this reaction is going to happen. We produced a solid. So we can go ahead and start writing the products for that. So that was silver phosphate, and we need to think about our charges here when we're balancing. Silver has a positive charge, nitrate has a negative charge. Potassium has a positive charge, phosphate has a -3 charge. So when I'm going to write the products over here, I need to keep those charges in mind to balance for the formulas. So silver is +1, phosphate is -3. So to balance those charges, I need 3 of the silvers. So remember, we use subscripts there. So Ag3, PO4 does not have charges because we just balanced the charges. But it does need a phase, and we just looked it up, and it was S because it was insoluble, so it's a solid. And now we have to write the other product, which would be now the combination of potassium and nitrate. Well, potassium's +1, nitrate's -1, so that's an easy formula. +1 -1 already cancels. Just to be safe here, we know it's going to be aqueous because this was the one that's solid, and just one needs to be solid. But we'll look up potassium and then nitrate, which is right here. It is indeed S, which means it's soluble, so it's aqueous. So this is aqueous. All right, and then the last thing we would need to do is balance this. That's the last step. So use your balancing skills, and again, treat your polyatomic ions as chunks. So you just go through. I usually start with the one on the left. So I have 1 silver over here. I have 3 on this side, which means I need to put a coefficient of 3 here. Once I do that, I'm now changing the number of nitrates. So now I have 3 nitrates here. So notice that the nitrates stay together as a chunk, so we can count them as a whole. So you have 3 on this side. I only have 1 on this side, so I'll need another coefficient 3 there. So now that I have 3 nitrates, it changes the number of potassiums to 3. So this side has 3 potassiums, and if we look on the left side, it also has 3 potassiums. So that's good. Those balance. Phosphates are 1 and 1. So those all balance out. So that looks good. That one's done. We've predicted the products. We know it happens because we get a solid, and we balanced the reaction. All right, so the next one. Next one we have calcium hydroxide and hydrochloric acid. So again, we'll switch our cations here. And then I'll go through and figure out the charges just to make it easier. That's a 2+, hydroxide's a -1, hydrogen's positive, chloride's negative. Alright, before we write our products, make sure this reaction happens. The first one we'll check if calcium and hydrogen switch places. We'll have calcium chloride as a product. So look on here, calcium chloride, It says S, which means aqueous. So far, that is not good for having a reaction. So we'll check hydrogen and hydroxide, H and OH. So we'll look up hydrogen, hydroxide. This one's quite interesting. It actually says H2O, and that's because hydrogen combined with hydroxide, HOH, that actually produces water. And if we look back at our notes here, that is one of the ways that we can have a reaction if we produce water. So this reaction will happen because of the combination of hydrogen and hydroxide. So we can write those products. So the first one we said was calcium chloride. Calcium has a 2+ charge, chloride has a -1. So in order to balance that, we need 2 chlorides there. And that phase we looked up was aqueous. Alright, so there's one product. And then the other product is the combination of H and OH, which is H2O. And the phase of H2O is a liquid, so I'll put an L there. And then again, the last thing we need to do is balance this. So I'll start on the left with calcium, 1 and 1, that's balanced. And then I'm going to skip to chlorine, because hydrogen's in a few things, so that's a little more complicated. But chlorine's just right here and here. I have 1 on this side, 2 on this side, which means I need a 2 here. And then oxygen we'll do next, because hydrogen is, again, all over the place. So oxygen, I have 2 on this side because of that little 2. Here I only have 1. So to fix that, I can add a 2 here. Now that we've taken care of everything else, now we can look at the hydrogens. And so we have 2 in this part of the equation and 2 in this part. So total on the left side, we have 4. And then on the right side, we have 2 times 2, so we also have 4. So now this equation is balanced. So that one's done. Alright, we'll do the last 2, number 4, number 5. If you are feeling confident, you can pause this and then try it on your own. And then check your answers. Give you a second to do that. And then I'll just go ahead and work through these, just like the other ones. Work a little quicker on these. So positive ions switch places. Remind myself of the charges here. So these switch. So one product we could have is calcium chloride. We just looked that one up, so I know that's aqueous. The other one would be hydrogen and nitrate. So hydrogen, nitrate, S, which is soluble, is aqueous. So 2 aqueous products. This reaction doesn't happen. Lucky us. Easy work. So since both products are aqueous, we don't get a reaction here. Alright, and then the last one. So these are going to switch. Charges, 2 plus, minus, plus, minus. Check our products. We're going to get, this time we'll have magnesium with hydroxide. Look at magnesium, hydroxide. Oh, it is insoluble, so that means solid. That means we're going to get a reaction. So right away from that, I know we're going to get a reaction. Magnesium's 2 plus, hydroxide's 1 minus. Remember, a very commonly missed formula here, you need the parentheses on the hydroxide. That one's a solid. The other one, just to be safe, potassium bromide, KBr. We've got potassium bromide is S, soluble as expected. So that's AQ. Alright, so that checks out. Then we need to balance always. Quickly here, Mg, 1 and 1, good. bromine. Bromine, we have 2 here, 1 here. So we'll make this a 2. That changes our potassiums. So we're going to need a 2 here. That changes our hydroxides. But luckily, we already have 2 on this side. So now it seems like everything is balanced, and that looks good. Alright, hopefully that is enough of a tutorial for you to get working on your predicting products homework assignment. Good luck.